Hello everyone. Now I'm going to talk about you introduce rate limiter based on the token bucket algorithm via Bucket4j into your application. And before we start, I want to introduce myself. My name is Max. I have around 8 years of commercial experience in Java. I work at Rook Solutions as a team leader. This company which provides authorization and notification solutions for the biggest company from Russia. So also I'm co-author of Bucket4j library. This is the most popular library in Java world, which providing rate limiting solutions. So also I'm co-author of the book. I released my first book 3 months ago. This book about how to realize RESTful API services based on the Spring framework. And in my spare time, I write articles for Java community and also I write scientific articles. And let's start. So what I'm going to talk about now. Let's talk about agenda. I divided this talk into 7 parts. The first part is what rate limiting is and where do you need to use it for. So um, I'll highlight the main areas where can we use rate limiter, and I'll explain what rate limiter is. The second point, I'll talk about main algorithms which providing rate limiters. I'll compare what's the difference between token bucket algorithm and liquid bucket algorithm. So the next point is I'll talk about advantages and disadvantages of the token bucket algorithm. So we have advantages and disadvantages of this algorithm actually. And the next point, I'll talk about main implementation of rate limiting. So in Java world, we have a few main implementations, and I'll try to compare these implementations. So Resilience4j, Google Guava, Bucket4j, I'll use it based on documentation level, based on functionality, and actually based on benchmark. I created micro benchmarking to provide really good comparison between these libraries. So, and after I'll explain why you should use Bucket4j based on main features which we implemented in our library. So I'll explain why you should use Bucket4j. And the next one point, I'll show a simple code example to start working with Bucket4j. And the next point, I'll show distributed code example based on in-memory database Hazelcast. So let's start. The first point, what rate limiter is. So in a few words, it's easy to understand the main idea. Rate limiter, this is a speed limit. It's used to control the speed of requests to your API from your server or from your API from your server to some API. So the main area to use rate limiter. I've highlighted 4 main areas to use rate limiter. So the first point, to protect our system from external requests. I'll not explain this point because in my opinion this is the most understandable point. The second point, to realize contract requirements. So we have 2 sub-points of this when we provide external API to the world and we want to earn money. So because based on this point we have to create verification levels. So to provide our API. So for example, we created a service which do something. So and we have a verification. Just for example, basic, business, and super mega premium. And based on these tariffs, we have some limit to use our API. For example, based on basic, so someone can call our API not more often than 100 times per 1 hour. At the same time, we have a business tariff, and someone can call our API not more often than 1000 times per 1 hour. At the same time, we have a premium tariff, and someone can call to our API not more often than 1 million times per 1 hour. So this is the main idea of certification. And we have second sub point. When we use this external service, which providing to us external API with certification, and we don't want to go out of limit. So the next point is to recognize fraud and anomaly detection. For example, use cases. Use case: when someone hacked your API of our forum and push and send 100 messages to our forum. So it's anomaly, and we should prevent this behavior because this is really a problem. The next point is to protect external system from us. So the main idea to prevent many requests from our server to other server. So it was the main areas where can we use this algorithm, and main algorithms which providing rate limiter. So I'll compare what's the difference between token bucket and liquid bucket. So as you can see to the picture, we have a bucket that holds a maximum number of tokens. So this is our capacity. And whenever a consumer wants to call to a service or to resource, he takes one or multiple tokens. So the consumer only consume a service if he take out required numbers of tokens. So if bucket does not contain the required number of tokens, he needs to wait until enough tokens are in the bucket. So, but when we have somebody who takes out our tokens, we also need someone who puts this token into the bucket. That's the job of refiller. So refiller refill every time tokens. So creates new tokens and put these tokens into the bucket. And now let's turn to code example. So wait a second. So this is a code example of realization in Java, this algorithm. So we have a bucket holds a few variables. So nanoseconds to generation, one token. So we should calculate this value based on limit. The next value, last refill nanotime. So we set this value every time after refill. The next one is capacity. This is maximum value of tokens into our bucket, and current state of our tokens, this available tokens. So the main idea here, when we can create a bucket, variables maximum count of tokens and current count of tokens are equals. So it means we have same value of these variables on the stage of initialization. And every time when we call to consume method, we call to refiller, which refill our tokens before we do consume. So, and the refiller based on these variables which I described before. So let's go to construct, and as you can see, construct takes permits and duration to create a limit for the bucket. So as you remember, I mentioned duration token, and we should calculate this value. For to do that, we just do periods divide on permits to get how much time we should spend to generate one token only. So the next variable is last refill in nanotime. This is current time on the stage of initialize. So for the future, we will refresh every time this variable. The next point, capacity and available tokens. These points in the stage of initialization are equals. So, and after available tokens will refresh after refill every time. So when someone called to try consume takes count of tokens which we should consume. We go inside and we call to refiller method. So let's see how this method works. For the first one, we should get current time. So this is now 10. The next one, in order, we should reduce the current time from the last refill time. So none is since last refill. So the next time we check if nanos to generation new token more than nanoseconds since last refill. This is the time has enough time passed for generation one or more tokens. So we just try to define, do we have time to generate one token or not? If not, we do return from the method. So at the next point, we should calculate how many tokens we can refill. So in order, we should divide nanoseconds since last refill to nanoseconds to generate token. So the next point, after when we refresh available tokens. So we have a problem. We can't overflow the bucket because we have a capacity, and we must set to available tokens the smallest value between capacity and current state of tokens. So to calculate current state of tokens, we should available tokens, current available tokens plus tokens since last refill, which we have already calculated above, just plus, and find which of these variables smallest. So, and in the next one, we should refresh the time of last refill. In order, we just multiple tokens since last refill on nanoseconds and just set into the last refill nanotime. So let's go into the next one and let's consider the liquid bucket algorithm. Let's turn to the liquid bucket algorithm. So as you can see on the picture, the liquid bucket algorithm has a very similar idea, but we don't consume tokens, we add these tokens. And every time when we have a full bucket, it means overflow and full, we should wait before we add new tokens. So every time when we try to add new tokens, we call to a lick method, which consume tokens based on the overrided rate. So it's like bundle widths in token bucket. So okay, we have looked at two algorithms for rate limiting, and now I would like to move to advantages of the token bucket algorithm. But before I start talking about token bucket algorithm, I should say in this wrapper I'll talk only about the token bucket algorithm, because token bucket algorithm is absolutely standard in programming world for providing features which I described before. And yeah, the main advantages is that this is less memory to use. So because as you remember on one of the previous screen about realization token bucket algorithm in Java, to realize this algorithm, we need only 4 variables. The first variable, this is volume of bucket, maximum possibility of tokens. So this variable consume 8 bytes because it's long value. So actually, all of these values are long in our bucket. The next variable, current count of tokens in a bucket, 8 bytes too. So the next variable is count of nanoseconds for generating a new value. This is 8 bytes too. And the next variable, last refill time, 8 bytes too. But because we work in Java, we have default object weight. So, and this header of object about 12 bytes for 64 DDK. And also, based on all of these variables and header of object, current weight of our object is 44 bytes. But for 64-bit GDK, our object should have weight multiple of 8 bytes. So, and plus 4 bytes for, in total we have 48 bytes. So this is the most important advantage, because very important to use less memory, because we usually store our buckets into random access memory. And for example, if we historically realize our algorithm, in theory we can store 21 million buckets into 1 gigabyte. This is really perfect. So but our algorithm is not perfect. We have a problem, and name of this problem called as the burst problem. So, and best explanation of this problem I can describe based on this screen. So let's imagine we have a bucket with the rule of consuming tokens not more often than 100 tokens in 1 minute. So, and let's imagine in some moments our bucket contains 100 tokens. At the same time, someone consumed 100 tokens. So for these two actions, we spent absolutely 0 seconds. Not absolutely, a few nanoseconds we spent to find current time. And after 1 second, refill again 100 tokens. So, but at the same time, somebody again consumed 100 tokens. And for these 4 actions, we spent 1 second, only 1 second. So, and in 1 second, we consume 200 tokens, and accordingly, we exceed the limit x2 times. It really sounds like a problem, but it's not a problem, absolutely not a problem, because it's a measurement error, and I will explain why. Let's imagine for 60 seconds. If we consume every time, each seconds, we consume only 6,100 tokens, and accordingly we exceed the limit no more than 0.17, 1.7%. So for 600 seconds we consume 16,100 tokens and exceed no more than 0.70%. But for 1 day measurement error will about 1 millionth of a percent. So it's absolutely not a problem, and this problem based on the main advantage. We cannot exactly express the contract to avoid the problem, because the main idea here to consuming less memory. I mean, to avoid consuming much memory. So, and let's go to the most popular libraries to compare. So I've highlighted 3 the most popular libraries which providing rate limiter solutions. So Bucket4j, Google Guava, and Resilience4j. And I really tried to create some comparison, but it was a little bit hard because, unfortunately, in my opinion, this library is uncomparable because only Bucket4j has everything. So I mean, has huge API, has opportunity to work with distributed realization. So as you can see, for the first point of my comparison, this point of documentation. So yeah, sure, Bucket4j, Google Lab, and Resilience4j describe everything. So as you can see, the second point, I think API supported only in Bucket4j and Resilience4j because partly Resilience4j created for reactive programming. So and the next point is really important because it's about implementation of many databases. So this point for work in distributed environment, and this point supported only in Bucket4j. So only with Bucket4j you can work with this point. The next point, based on previous point, it's opportunity for custom implementation with other database, and this point supported only in Bucket4j. So because for to do that you have to implement 2 classes and override a few methods to start working with new database. So you can start working with your custom database. I don't know, with VaultDB you can start working with MySQL, PostgreSQL, MongoDB, absolutely everything. You just need to override a few methods and other API. When I create this point, I thought maybe someone has much more API related with rate limiting. Not, unfortunately, no. Bucket4j has more than 15 methods to work with rate limiting, so we have many features. But Google Go and Resilience4j has only methods from the main algorithm. So, and let's go to compare based on My micro benchmarking. I created my micro benchmarking based on Java micro benchmarking harness. This is the most popular library to realize micro benchmarking in Java. So since Java 9, this is part of OpenJDK. So, and before we start, let's consider legend map. So 1 microsecond consists of 1000 nanoseconds, 1 millisecond consists of 1 million nanosecond. Obviously, this is operation. This is microsecond, and error, this is not error, this measurement error. So, and I created this point, this micro benchmark with two modes, throughput mode and average time mode. So this micro benchmark has a result of speed with high thread contention, so in 4 parallel thread. And as you can see on the left side of this screen, to the left table in throughput mode. So the main idea of throughput mode, the bigger operation per microsecond, the better. This is operation per 1 microsecond. And as you can see in high thread for parallel contention, Bucket4j absolutely leader here in this comparison, because Bucket4j can consume about 13 operations per 1 microsecond. So as you can see on the right table, Bucket4j absolutely leader here, because this is average time in microseconds to 1 operation. So how much time we should spend per 1 operation. But before we continue, I want to say these numbers, these values, are absolutely unnecessary to know. So these numbers are absolutely useless. I will a little bit explain why. So let's go to the next point. This is absolutely same micro benchmark. So, but without thread parallel contention, I run this micro benchmarking only in one thread. As you can see, Bucket4j here is absolute result. Bucket4j can do 37 operation per 1 microsecond. So it's really huge. So, and as you can see on the right side, this average time mode, Bucket4j absolutely leader here too. So, and actually this screen, it's not a benchmark. This is a result of memory benchmark partly. So this is how much memory we spent per 1 operation of try consume. So when we call the try consume method, how much memory we spend for to do that. And as you can see, follow this realization, Bucket4j synchronized spent absolutely 0 and absolutely here. Again, Guava spent 24 and Resilience4j about 40. So, but unfortunately, Bucket4j log3 implementation spent really too much, so about 64. So, and going to the next one, all of this micro benchmarking you can find following by this link, and you can see realization how we realized this thing. So, and each test was run x2 times, x2 x10 operations. So as you remember, I wanted to explain why all of these numbers are not important, why these values and numbers are useless, and all of this benchmark have a very similar values. So to understand that, let's go one of the previous screen with speed benchmark. Yeah, sure, that's a good example. So let's base our example on Google Guava. And yeah, sure, Bucket4j faster, but it doesn't matter, absolutely doesn't matter. We can work with Google Guava, we can work with Resilience4j. If you don't need some huge API, you can work with each of these library. And I'll explain why. So let's imagine. Okay, no, I know better. So our test based on 1 microsecond. 1 millisecond consists of 1000 microseconds. To feel some problem with consuming operation, to feel some problem with performance, you should call more than 10 times per 1 microsecond. So, I mean, when we use Google Guava, because Google Guava have 9.4 operation per 1 microsecond. But let's imagine you use 10 times per 1 microsecond. Only at this point you will feel some problem. So to understand this value, you can to understand this value, let's remind one 1 microsecond consists of 1 millisecond consists of 1000 microseconds, and to feel the problem you should call 10,000 times per 1 millisecond. So really too much. Or you should call 10 million times per 1 second for 1 bucket. Have someone ever seen this with some highlight system? I think nobody never seen this before, because I've never seen, and I think it's not possible, because one token call 10 million times per 1 bucket. I think it's not possible. And also, as you remember, every time when we use consume, we use 24 bytes per 1 operation in yes, in this Google Guava. So per operation, it means we immediately consume 200 megabytes, because each call to consume method consuming about 24 bytes. So for 1 second, 20 megabytes, it's really too much. And now let's consider Bucket4j. So what is Bucket4j? This is the most popular library in our world for realization rate limiting features. Every month, Bucket4j downloads up to 200,000 times from Mobile Central and contained and 3,500 dependencies on GitHub. So use it in Kubernetes, Java Client, JHeaps, Atlassian, Twitch, and many different libraries used. So now I'll explain why you should use Bucket4j based on the main features which implemented in our library. So, and as you can see on the pictures, I can say it's only main features. It's none of all features. So only features the most frequently used in Java world. So the first features from the basic functionality. This is opportunity to work with multi-bundle with management. So where is that? In our library, we extend our token bucket algorithm. So you can work with not only one limit. You can work with 3, 5, 7 limits. Usually it's unnecessary. It's absolutely no need, but you can work with 2, 3, 5 limits, and it works per 1 bucket only. So the next point is specifying initial amounts of token. You can set on the stage of initialize counts of tokens, start counts of tokens. Usually that's due to avoid burning at the start of creating your bucket. So because usually in standard when we create our bucket, capacity and available tokens have similar value. So the next one, turning off their field greatness. So you can set your custom time for field tokens in your bucket. For example, let's imagine we have a bundle width with a limit, not more often per 10, not more often tokens to consume, 10 tokens to consume, not more often than in 1 minute. So, and if we turn off this functionality, so using this API, so each 10 seconds we generate 10 tokens. So it means when we use basic API, each 1 second we generate 1 token. So using this API, only per 10 seconds we generate 10 tokens. So turning off the refill greatness. The next point is blocking KPI. This opportunity to block your threads up to this time when requested counts of the token will generate. So we just set time, and up to this time we're gonna wait. So to method try consume. Now we're going to distributed features and distributed objects, and let's start from distributed implementations. So we have integration with Apache Ignite, Hazelcast integration, we have Infinity Span integration, Oracle Coherent integration, Redis integration, and DynamoDB integration. So, and also we have with JCache integration. So, and as you know, Apache Ignite, Hazelcast, Infinity Span, and Oracle Coherence has very similar API because all of this cache, all of this in-memory database based on JCache, which based on JSR 107 Java specification request. In this request, described how to create your cache and JCache based on this specification request. So also we have framework to implement with your custom database. As you remember, one of the first screen I said about that. All what you need to do to start working with your custom database, you need to implement and start working with two classes. So extend from abstract to log-based proxy manager and implement log-based transaction. In total, you should implement and override about 10 methods. So, and you can work with each database which you want. So, MongoDB, MySQL, PostgreSQL, VoltDB, other else. So, OracleDB maybe. Let's go to the next feature. So, it's Async API. This just to realize non-blocking API. So, to start working with in non-blocking environment. So, just for example, this is one of the main principles of reactive. Usually it using in reactive programming. So about the batching API. So the main idea of batching API to collect tokens in batch and set not every time when we call try consume. So that only time when getting a result of executing from previous time. So and also we have another strategy of this one. So and also we have two strategies of batching. The first strategy I said already, and the second strategy based on collecting time and numbers of token. And when we execute one of this variable, just for example collecting time, we send into the database. For example, we set collecting time 1 second and set number of tokens equals 100. And for example, if we have already wait 1 second, but we don't have numbers of tokens, we can batch of all our requests and send in memory database or in the database. Or we have already collected count of tokens, and after just collect and send and send. So, and we have actually advanced features. So this is really a huge topic when I start talking about advanced features, but in a few words I'll talk about that. So we have monitoring KPI. Listening for bucket events at the same time called as monitoring KPI. This is opportunity to monitor actions of buckets through the listener. So we can listen many things which related with our bucket. For example, when token consumed from bucket, when contribution request was rejected by bucket, when thread was parked for wait of tokens refill in result of interaction with blocking bucket, and many different things we can listen related with our tokens through the listener. The next one is verbose API. So at the same time called as diagnostic API. So this is a point to investigate behavior of our bucket. So you can get more detailed answer of working of our bucket. Why our bucket gave to us at some moment false. So and based on which bundle widths we got false or true. Based on which bundle widths we get true, based on which limit, short or long. So we can investigate behavior of our token, of our bucket. Sorry. The next point, on-the-fly configuration replacement. This is opportunity to reconfigure bucket. Just for example, you can change the maximum count of tokens, or you can change the maximum time of your bucket to refill. So you can change this variable without recreating of bucket. So to try to save previous values. And the next point is scheduler API. So the main idea here, when we use try consume, we set number of tokens, we set maximum waiting time, and we set scheduler. And as a return, we just return completable feature. So it was only main features which I describe it now. But let's go to the simple code example. So this is a simple implementation to start working with Bucket4j. And in here, for example, you can see bundle widths with a rule, 1 token per 1 minute. So the next one, we create the bucket and set bundle widths which we created above. So and set this bundle widths into our bucket. The next one we call method try to consume to set counts of token to take from the buckets, and return boolean. So this method return boolean. If true, successful, and the bucket had enough tokens inside the bucket to execute method try consume. If false, we don't have enough token at the same time as this time. So this try consume will return true. The next one is we call method try consume and return remaining and return remaining. So and set count of tokens into this method. How many tokens we want to consume. So this method return contribution prop, which include much more information, have more detailed answer, and returns a few variables such as is consumed. So when we call to this method, we're getting a result of calling our try consume. So we perform it or not. So successful our result or not. The next one variable, when we call to get remaining tokens, we return a current state of remaining tokens in the bucket. And the next one point is get nanos to wait for refill. So this is time in nanosecond to refill tokens in our bucket. So as you can see in the picture, the first point, the first method is consumed will return false because we have already called method try consume, and bundle with management has a limit with a rule 1 token per 1 minute. The next point will return 0 since we have already consumed all of the tokens based on this bundle with management, and the next point will return around 6 million nanoseconds based on bundle with management. Let's go to the next example. This is multi-bundle with bundles with management example. As you can see, we have 2 bundle with management. The first one, not more often than 10 tokens per 10 seconds, and the next point is not more often than 2 tokens per 1 second. And we set these rules into our bucket, and after call 2 times try consume, and which time try consume we set 2 tokens, and this try consume will return true because based on First bundle width. All right, all perfect. We consumed only 2 tokens. Base it on the second bundle width. All right, all perfect. We consumed 2 tokens in 1 second. But when we use the second try consume, we're out of limit on the second bundle width. Not more often than 2 tokens per 1 second. So going to the next example. This example a little bit interesting. Because this is distributed example. So as you can see, we initialize Hazelcast instance. So and we initialize that based on Hazelcast config, which you can overwrite and set your custom variables, such like this your custom configuration of your client. You can set host, you can set credentials, you can set strategy of working of your clients, you can set everything to start working with your client. The next point is we're getting map with our buckets. And the next point, this is Bucket4j object, proxy manager. We set in this project manager, in the station initialize our buckets. So, and proxy manager also based on entry processor. So this is mechanism which allows execute Java code on the database side. So entry processors in effect this alternative transaction by 1K, and accordingly we guarantee by one object we can execute entry processor, one entry processor per one time. So in short, I mean, an entry processor, this is a function that executes our code in an atomic way. So let's consider. So we have absolutely the same configuration like it was previous time with this example. So multi-bundle with example, and the result was absolutely same. So we put our bucket into the database, and we use try consume. The first try consume will return true, and the second one try consume will return false, based on the second one bundle width. So thank you so much for your attention. I hope you will use Bucket4j library for realizing rate limiting into your application. So thank you so much. Bye.